Good morning, dear students. I am Upendra Rao, working as a Deputy General Manager in State Bank of India. I had 27 years of experience in IT area, experience in implementing different projects including data warehousing. I worked as a professor and a director in Central University of Hyderabad, previously also in Andhra University Engineering College. Then before that I was in TISCO as a system engineer. Today I am going to discuss about data warehouse implementation methodology and different architectural options. First, define data warehousing definition for completeness sake. Data warehouse is a copy of transaction data specifically structured to query and analysis. What is meant by copy? A copy of data warehouse are not transactional systems. A copy of data taken at a snapshot in time. The snapshot is defined depending on the organization and the durations depending on the kind of business. All transaction data warehouses do not present any information that is not already captured in the enterprise. Today, you want to build a data warehouse for a business intelligence purpose. If I don't capture some basic information, for example related to the date of birth of an employee, I am not able to analyze anything based on the age profile of the employees. That means we have to capture the basic data in the transaction system. We cannot build up anything other than transaction data into the data warehouse. That's why it is all transaction data. It is specifically designed, means traditional relational models do not apply here. Traditionally, what we do in building a database, we normalize the data for reducing the redundancy. But in the data warehouse, we go towards denormalization because the data is very large in size. In order to achieve the efficiency, we have to go for a denormalization. Let's see now what we have in data warehouse, the components, the facts and dimensions. Based on that, we are going to build a data warehouse and extract the business intelligence information from the data warehouse. What are the facts? The facts are quantifiable measures of business attributes. Dimensions, they are the characteristics of which giving a fact a meaning. Take an example. I have different dimensions of a business: a gender, product, time and segment. For the gender dimension, I have facts male or female. Similarly, for other dimensions, I have different facts. The time dimension has facts like day, week, month, quarterly or year. Segment, industrial segment, small scale industries, agriculture industries, like that. So if you look at these dimensions and facts, I am building a data warehouse based on these dimensions and facts. What for? To analyze the business threats. The business threats can happen. Now the components of data warehouse consist of dimensions and facts. See, if you see in this example, we have 4 dimensions. Corresponding to each dimension, there are a number of facts. My business can have a threat in any one dimension or multiple dimensions. So the threat can be in a gender. My business, many of the females are not buying a product, or maybe a product, that particular product is not taken by the people, or maybe in a time, or maybe in the segment. So that means my business can have a threat in single dimension or in multiple dimensions. So if you look at it, these 4 dimensions itself, how many number of threats my business can have? Factorial 4 dimensions. That means I need to analyze, identify the threat in which is happening to my business. That's how I am going to build a data warehouse and analyze it. So that means now I designed my data warehouse for complete dimensions and fill the facts into the dimensions and start analyzing it. So for completeness of data warehouse, I need to identify all the dimensions of my business. From here, you can understand as the dimensions are increasing, number of threats to the business also increases. Now, for building a data warehouse, we identify all the dimensions of the business and then design the data warehouse and implement it. Now we will see how to implement a data warehouse. What are the methodologies of implementing a data warehouse? You should have an implementation plan. The plan consists of start with the project planning, analysis, design and construction. The first two phases, project planning and analysis, involves mostly the business information, business related tasks, whereas design and construction are purely technical related tasks. We have to spend more time on project planning and analysis, then we can go for design and construction. See the project planning. The project planning, we have to identify the stakeholders, scope definition and work plan. In the analysis phase, we have to identify the fact definition, dimension definition, the requirements definition. What kind of requirements are required for the stakeholders of the business based on these facts and dimensions. That's what the requirement definition. Then design and construction. Now let us take the stakeholders. I take an example related to a large bank. The bank, different kind of stakeholders will be present. Let's say strategic stakeholders, reporting stakeholders, operational stakeholders. The strategic stakeholders mean generally chief general managers, deputy managing directors. They will be requiring the long range business intelligence information that is obtained from the data warehouse of the whole bank level, whole the organization level. And below that, the bank is divided into different circles. Each circle will be headed by a group of people running. They will be requiring the management reporting information. Reporting stakeholders like circles, chief financial officers, deputy general managers or general managers. They will also be requiring a solution of data warehouse with reference to their circle. Now, operating stakeholders, they don't require the full knowledge of the whole bank level information. They require a segment of the organizational information that we call as a data mart. So, for example, for them, regional managers and branch managers. That means in the case of a bank, we have different kind of stakeholders. We need to identify who are the stakeholders, what kind of solution they require, a data warehouse or a data mart, identify their requirement and build the data warehouse meeting their business requirement. In the stakeholder definition, we have to clearly define the stakeholder definition document. When you start building a data warehouse implementation, who are all the stakeholders, list out the names, what is the job title and their profession, job function, and each planning stage, what role they are going to play, who are going to play, what role they are going to play. Define a matrix like this. So, for example, in this case, a person 1, Chief Information Officer, he will be a stakeholder definition, he will be involved in the statement of scope and assumptions, and he need not involve in the work plan. So, this CIO, Director of Application, CFO, these are all people who are involved in the project planning stage in defining the stakeholder definition, each stakeholder, what is required for them. In a work plan stage, all people need not be involved. Only, for example, here, Chief Financial Officer, the work plan, and Information System Project Manager. These two are enough to involve in the project planning, work plan stage. So we need to define a stakeholder definition matrix, deciding who are the stakeholders, what are the roles in each phase. The project planning, these are the roles. In the analysis phase, these are the roles of the stakeholders. See, in the case of analysis, operational requirements, all the people are mostly involved. The fact definition stage, system analyst people are not, the technical people, these need not be involved. Only the top management people are enough to be involved. Similarly, the dimension definition. In operation requirements, all people need to be involved. Similarly, for design stage, design is mostly technical related job. Therefore, The top people need not be involved. Functional analyst, financial analyst, information system project managers, IS analyst, these are the people, down the people are need to be involved in the project. Similarly, construction. The construction again is a pure technical job, therefore only the information system analysts are involved in this case. Testing. While testing the system, we need to involve again the technical people as well as the business people. Therefore, we will be involving some of the financial analyst and project manager and system analyst. So, when we define the stakeholder statement, stakeholder definition statement using this matrix, similarly in the implementation plan, the top people need to be involved. Therefore, these two are also, role is defined for them. Now, after defining the stakeholder definition statement, I have to write down stakeholder definition document stating what is the functionality in scope, what is the functionality out of the scope, under what assumptions I am building the data warehouse. This is very important because the functionality in scope and functionality out of scope facilitate the implementation of the data warehousing project in a time-bound manner, in a smooth way. Suppose functionality in scope, that gives a clarity for all the people of the stakeholder. We have considered only these issues to be built in the first phase. Because some of the issues we have deferred because of these reasons. This issue is not accounted in this one to build in the data warehouse because it is going to have more cost or some of the data is not clear. So those, what is functionality in scope, what is the function out of scope? If I clearly define the scope definition document, that will guide all the people to implement smoothly. Otherwise what happens, if I don't define the scope definition document, at the middle of the stage, some influential top management person may come, I want this requirement to be added into the data warehouse. Then what happens? You can't say no to him. We try to introduce his requirements to data warehouse, then the scope increases, you need to redesign it and the project implementation get delayed. So you need to understand the defining the scope, functionality in scope, functional out of scope. Not only defining it, you have to document it, well documented, and to be circulated all the stakeholders so that they are guided on a single base platform to implement the data warehouse for its success. And what assumptions I am building the data warehouse? Assuming that I am building a data warehouse in the organization, I have different sufficient technical people. Yes, based on that assumption, if I am building a data warehouse based on the Oracle data warehouse, Oracle expertise is available. I am assuming that. These assumptions I started. So after some time, if I don't have technical people, then my project will be delayed. I am analyzing why the project is delayed. I have started with the wrong assumption. That's why the project is delayed. So that I can derive why the problem, I can monitor or derive what is happening related to the data warehouse project implementation. Now let us go for a data warehouse implementation plan. Traditional implementation. Let us discuss scope holders definition statement. We need to define this scope holders definition covering the functionality in scope, functionality out of the scope, and under what assumptions we are going to build the data warehouse. This is very essential for the smooth implementation of the data warehouse project. What are the functions I am going to include today in my building a data warehouse? What are the functions I am not keeping inside the data warehouse because of these reasons? Under what assumptions I am building the data warehouse? These three factors are to be documented perfectly so that all the stakeholders are guided by this document so that implementation will go smoothly. Suppose if I don't define the scope document properly, an influential stakeholder may come in between and ask for additional requirement. To include that additional requirement, you may have to increase the scope of the statement. Thereby you need to redesign the data warehouse. So it's going to delay the project. That's why this scope definition document is essential for the implementation of the data warehousing project. And also we need to define under what assumptions I am building the data warehouse. Assume that I am building a data warehouse using Oracle tools. Oracle expertise is available in my organization. If I assume that I plan my data warehouse construction over a period of 3 months or 6 months time. So if my project is get delayed, then if I analyze why it is get delayed, if the data house workfield experts are not available in the organization, then my project will fail. I can understand why the project is getting delayed with reference to the assumptions, and I can validate and find out. Therefore, in the scope definition document, we need to clearly specify functionality in scope, functionality out of the scope, and under what assumptions I am building the data warehouse. Now let us go to the next step of implementation. The data warehouse implementation, generally people go by a traditional model, traditional implementation. What we do in this traditional implementation? We analyze, do the analysis, design the data warehouse for all dimensions and all fact process, construct the data warehouse for all dimensions and all fact process, and test for all dimensions and fact process, implement for all dimensions and fact process. That means I am building a data warehouse for all dimension fact process at each stage of the construction process. That is the traditional model. Generally, this traditional model likely to fail for large projects, and also is going to take a long time. So the experience shows that it is not a preferable methodology in implementing a data warehouse, especially in a large organizations. So what are the alternate options available to implement a data warehouse? See the next model. This is called stage implementation. What I do in the stage implementation, I do the analysis and design, construction, implementation for all dimensions. I should not leave any dimensions at the beginning of the data warehouse design, because adding a new dimension at a later stage is going to take more time and it is difficult to redesign the whole product. Therefore, all dimensions have to be comprehensively collected, analyzed, and all dimensions need to be implemented at one stage. And the next stage is what we do: design, construct, implement for few facts. Let us say for facts 1, 2, 3. See the results. Learn the mistakes from this implementation of few facts. Not repeat in the second step. This implementation I define as implementation 1. Next I take up design, construct, implementation for next set of facts. Let us say 3 to 6 facts. Implementation 2. Next, like this I go on taking a few set of facts and start implementing the data warehouse. The advantage is that in each stage of implementation I will be learning from mistakes. Therefore, probability of success of the project is very high in a stage implementation. Especially this methodology is suits for a very large organizations. We have seen the implementation methodology, or a traditional methodology or a staged methodology. The small organizations, small requirement, traditional model can be applied, whereas in the big organizations, large data warehouse requirements, stage implementation is a suitable one. Now I am going to discuss the data warehouse implementation with reference to the large organizations, and what architecture I will select for implementing the data warehouse. There is no prescriptive rule for defining this is an architecture suitable for all the organization. Depending on the kind of an organization, depending on the type of the business they do, depending on the kind of culture they have in the organization, different kinds of architecture are suitable for different kind of organization. Let's go to the next step on architectural options of building a data warehouse. Data warehouse architectural options. Mainly I classify into 3 categories of architectural option. Centralized option versus distributed data warehouse option. Data warehouse option versus data mart option. Horizontal versus vertical. Let's understand these terms properly. Centralized versus distributed. all the data related to the complete organization is centralized at one place, that is centralized, or I distribute the data in different systems and different places, that is distributed. Data warehouse versus data mart. Full data of the organization for all the people I build up data warehouse, or data mart is only a subset of people I build a data warehouse. I build a data warehouse for a subset of employees in the organization to specific business requirements. That is called a data mart. Do I build a data warehouse or do I build a data mart? That means building a different data marts for one set of people, next I build a data mart for second set of people, next I build a data mart for third set of people. Like that I can cover all employees in the organization. Ultimately it will become a data warehouse for the organization. That is one architecture option. Another one is horizontal versus vertical. Horizontal means all business units I will consider and start building a data warehouse. Or I take one business unit, for example, in a banking scenario, I take one business unit like housing finance is a one business unit. I build a data warehouse for housing finance. Loan is treated under credit. Credit is one vertical. Credit business, that is a loan business, one vertical I build up. So vertical by vertical I build up. Ultimately I build a data warehouse, or I take a horizontal approach. Which approach is suitable for the organization? All depends on the different factors, and then give us different architectural options. Let's go in detail. What are those architectural options? How the data warehouse is implemented? Centralized architecture. I am explaining this architectural option with reference to a bank, very large bank. Let's take a centralized architecture. We have a bank. Banks will have different branches across the country. The country is divided into different circles. Circle is a segment of the country. Maybe one state can be taken as a one circle. So I collect data from the branches across the country. That means across all the circles. Put the data in a centralized data warehouse and allow the people, top management people, to access the business intelligence information from the data warehouse, like circle chief general managers, corporate center chief general managers, board members of the bank. That means I am building a centralized data warehouse here. Here the question comes, what level of granularity of data I am going to populate in my centralized data warehouse? Granularity is the level of summarization of data which I am going to bring from the different branches into the central data warehouse. That is called granularity. I may bring by single transaction to my data warehouse. That we call as a fine grained granularity. Summarized transaction of the customer I may build up here. That is slightly coarse grained granularity. Or I may just simply summarize the whole branch level profit and loss related statement. That summarized transaction, higher level of granularity, I can bring it here. So the level of granularity I need to decide depending on the stakeholders' requirement. If they are the top executives, they may not need to analyze the fine level of granularity of data and get the information. Whereas the operating people, they will be requiring the analysis on the fine grained granular data. So whom I am providing the access? Why I am building the data warehouse? What level of granularity I need to decide is based on the stakeholders' information requirements. So this one is the centralized data warehouse. What is the pros and cons of this approach? Let's see the pros. There is a single point integrated view. I am going to get a single point integrated view of the whole organization in this process. It reduced operational complexity. Since I am building the data warehouse in a central place, I require only one hardware, one set of people, or therefore the complexity, I need to operate from single place, therefore operation complexity is simple. These are the advantages of the centralized architecture. What are the disadvantages, the cons of the centralized data warehouse architecture? Long gestation period. It is not easy to build a data warehouse in a shorter period of time, this kind of an architecture. I need to understand the whole organization, all stakeholders' requirement, and design the granularity and build up a data warehouse. So it takes a long gestation. To know the results, I have to wait maybe more than 1 year or 2 years or 3 years time. That's a long gestation period. We require a supercomputer hardware requirement because I am going to build all data in one place. The processing is going to increase. The response time I have to get in a very faster way for all the stakeholders. Therefore, I require a supercomputer there. Single point failure or reduced availability. Some problem comes in the central place, no stakeholders can access. Reduced availability, system is not available for any stakeholders, all stakeholders, the system is not available. So, availability is reduced, single point failure. These are the cons. Now let us go to the next architecture model, distributed architecture. What I do here, I take up one circle, let us say one state, collect the data from different branches of the bank, build a circle level, one circle level data warehouse. Similarly, for another circle, in another state, I build a circle level data warehouse. So what I am doing, I am distributing the data at different circles, not at a central place. So since I am distributing the data in a different circle, I define my granularity as a fine-grained granularity. Then from the fine-grained granular data of the circle-level data warehouse, I summarize the data from each circle, bring it to the central place, corporate data warehouse. So in the corporate data warehouse, I can make the data as a coarse-grained data. So here what I am doing, the data warehouse is distributed across the circles, and this gives the circle level data warehouse, circle level people, they will be reporting information, monitoring information, they will be obtaining from this data warehouse the circle level access points to the circle level access points, and whereas the corporate people, strategic information based on the summarized data, they will be accessing the information from their access points. So this is the distributed. What are the pros and cons now of this model?
Now my question to you is, can the circle level managers access the coarse-grained data warehouse? Means, is it possible to access the data from the corporate data warehouse created for CGMs and board members information? Will it be accessible to circle level people in your architecture?
A good question. Now the question is whether the circle level stakeholder can they access the coarse-grained data which is meant for the top level executives of the organization. We are building the data at different stages. The access permissions depending on how I am going to configure the system. These people, these are all networked. If I configure here to allow these people also to access this one, they can access it. Generally that does not, in practice that does not happen. The circle level stakeholders are the reporting stakeholders, monitoring and management purpose, whereas strategic stakeholders are for a strategic, corporate stakeholders are for a strategic purpose. Therefore, generally the access restrictions based on the business requirement, they restrict like that. Technically it is feasible, practically they do not implement like that. Now let us come to the pros and cons of the distributed architecture. The pros of a distributed all data is centralized. Therefore, circle cannot access its own data if there is a problem at this level. Now here, even though the problem at this level of corporate data warehouse, circle are independent of this one centralized data warehouse. Therefore, they are circle level independency. Distributed computing power. I don't require a supercomputer here because I am building a summarized data here. Each circle I have another mini computer. And then high availability. If the computer is down here, circle level people, because of the independency, they can access the information. If this circle is down, they can access other circle people are using. That means availability of the system is there for a group of people, employees in the organization. Where in the centralized architecture, the central system is down, not available for any of the employees. That is the pros of this one. Let's come to the disadvantage, the cons. Operational complexity. I am building the different systems and tools at different places. Large number of systems, maybe a mini computers, the set of tools here, and set of people here, and at some corporate center set of people here, and set of tools here. That means the complexity of operation increases as the number of size of the organization increases. High cost. In each place, the costs are involved, therefore the high cost model. This is a distributed model. Now let us go to the next options. Data warehouse architecture. What is meant by data warehouse architecture? Warehouse approach. Warehouse, what you do in the warehouse? Everything you dump in the warehouse. So that means all enterprise elements of the data you are going to put into this one with reference to the bank, credit related information, foreign exchange related information, personal banking related information. The banks do a government business, that information, all business information related to the enterprise you are going to put in the data. That is called as a data warehouse approach. Whether I do it as centralized or do it distributed, we have seen previously. Now we are going to see what is the approach, warehouse approach or non-warehouse. That is the marked approach. This is the data warehouse architecture. What is advantage? Enterprise integrated view. Serve the long-term requirements, because in the long term, what purpose I am building the data house, considering all informations, all 360-degree view of the business I am going to analyze based on the enterprise data elements. Therefore, the long-term requirement and operational simplicity. So I need not again check for the integrity, consistency of the data put in different places. So that is an advantage of the data warehouse. What is the advantage? Very risky. It is very difficult to view 360-degree views, 360-degree view of the organization, collect all the business requirements of all the stakeholders for all the businesses, build a data house, and long waiting time for results, just like in the kind of a centralized data warehouse model. Next approach versus the data warehouses versus the data mart architecture. I take one application, the credit information application, I build a data warehouse. We don't call it as a data warehouse, it's a data mart, because it's not for the whole elements are not belong to the whole organization, it's a part of the organization. So I build a data mart for one application, that is the stage 1. Then next, I learn from the mistakes of this application. Do not repeat those mistakes in the second stage. Take up another application, personal banking, build a data mart, the stage 2. Like this, I will go on building different data marts, and then ultimately I build a data warehouse from all the different data marts. This is the data mart architecture approach of building a data warehouse. What are the pros? Delivers results in a short time. I need not wait for a long time, collect the requirements, design the system, and implementation. There's long these results need not wait. This small application I can do in a shorter time. Learn from the previous mistakes here, need not be repeated here. Mistakes generated here need not be repeated here, so that as the stages go on, going the next stages, number of mistakes will get reduced by experience. That gives the better results in building a data warehouse. guaranteed return on investment. This approach generally suggests return on investment. We are not going to invest at a time for all the hardware, all the people, all the tools, everything, analysis, all this thing, not at one time. Like in a data warehouse, I am going to invest at a different stages. X investment here, X plus delta investment here, X plus 2 delta investment here, like that. Therefore, it gives the guaranteed return of investment. What are the cons? Satisfies specific group of users. The problem here in a data mart architecture, when I am building a data mart for a credit information system, the people in this credit information system will be well satisfied. They feel that they are alienated by the organization, whereas the other segment people, they feel that we are being neglected. That means there are some kind of interpersonal relationship problems will come up. These people in this other department may say these are the blue-eyed boys of the organization, therefore they are being taken a first, they are given more preference over others. So, they satisfy specific group of users. In that process, while building the subsequent stages of the data mart, they may not cooperate. They may not cooperate satisfactorily. That issues may come up. Segmental view, I am not going to get the complete organizational view by building a mart approach. One view, another segment view, another segment view. At later stage, I need to combine all the views. There is also an issue in integrating all the views into a single view. Enterprise integration issues. So when I build each data mart separately, how to integrate, if I don't plan it properly, integration issues crop up. And higher cost in the long term. I have to pay more cost different because of the stages of different implementation. These are the disadvantages of data mart architecture. Now, I am using a new architecture model, centralized vertical data mart. We understood what is a centralized architecture, what is a distributed architecture. Now I am using a word centralized vertical data mart. So as I defined, horizontal versus vertical. Horizontal is across the business unit, vertical is belong to a single business unit. For a single business, centralized data mart. I am calling it for a single business, it is a centralized approach. It is a data mart. It is not a data warehouse for the organization. So the architecture, how it looks? I am building a centralized, therefore all data will be at central level, one place, therefore it is generally fine-grained data. I have to build from all branches, vertical for one system of credit information system, build up here the bank level, fine-grained data, allow the people to access different stages. So this is a centralized vertical data mart approach. Distributed vertical data mart, another architecture option. See here the fine difference. Distributed, vertical. Vertical is distributed, and since it is a vertical, it is not a data warehouse, it is a data mart. For one circle, I take only one application. For all branches, build up for one application, build a data mart. Circle 2, build a data mart. This is the fine level data, fine grain level data, and summarized data are built into the bank level, coarse grain data. Then I allow the corporate level access people to use this information. So what did I do here? I took one application, distributed across the circles, and build a data mart for the organization. So now you have seen different options of building a data warehouse. Data warehouse centralized versus distributed, data warehouse versus mart approach, horizontal versus vertical approach. What approach is suitable for an organization is not simple to answer. You have to understand the organization, the procedures, the culture, the policies, the investment we are going to, management is trying to commit, all the factors, then the resources we have in the organization, this is also another factor. All these things need to be considered in design. Now I am going to present one scenario for a large organization. What is the best model, a generic best model we can adopt for implementing a data warehouse in case of a large organization, specific to the banking which I am explaining now. The approach which I am going to adopt stage by stage, but each approach what product I am going to get it. Because we already know, understood what is the definition of a data warehouse, data mart, with horizontal, vertical. Based on this, we define a generic approach for large organizations to implement a data warehouse. Take this. Stage 1, distributed vertical data mart. What I do, different states take one application of credit information, build a data mart. What is the product I am getting? For each circle level, I am getting a data mart related to credit information. I see for this credit information, circle level, is it satisfactory for all the stakeholders of circle? Yes, satisfied. Now I am going to add more applications. Now I am going to build up the central level, centralized vertical data mart. Now I am going to build up the distributed data, bring it summarized data into a central place, that is corporate central level data mart. So I have completed for one business unit data mart. I have completed one business unit building a business information for one vertical, that is by corporate center level data mart. What is the approach I have? Centralized vertical data warehouse. Next is distributed horizontal data mart. What I do now, one application, business application I build up, mart, then build up the warehouse for that vertical, then I am going to add another applications, housing finance related, retail business related, agriculture business related. One by one I am going to add up, that is horizontal, across the business unit, distributed across the different states, different circles, I am going to build up this one. That means I am going to build a circle level data warehouse. For circle is a complete data. For all applications, complete data I am building up at circle level, that is a circle level data warehouse. Then I bring up the summarized data into central place, so centralized horizontal data warehouse, that is a corporate level data warehouse. So in a staged manner I am going to build up a organizational level data warehouse, covers all the business units, gives the information, business intelligence information requirements for all the stakeholders. So this is one approach. That does not mean that this approach is suitable for all organizations. It is a generic approach we have discussed. We say that generally suitable for a large organizations, but depending on the size of the organization, depending on the size of the business, we have to say what kind of an architecture, where to start and where to end. This is a part of the planning process need to be done by the stakeholders at the beginning of the building a data warehouse. Thank you.